Hello, here we are again doing whiteboard problem 3 for chapter 8. Okay, we have a Stone Age hunter places a 1 kilogram rock in a sling, so my mass is 1 kilogram, and swings it in a horizontal circle around his head on a 1 meter long vine. So I'm going to write down L is 1 meter. If the vine breaks at a tension of 200 newtons, T max equals 200 newtons. What's the maximum angular speed in RPM with which he can swing the rock? So we want to find omega in RPM. Okay, so let's switch over to our camera here. All right, so we have that. We have our, I think I'm going to really try and draw the hunter. I guess I could. Why not? That's the fun part, right? So we have hand up there and swinging the rock at some angle, and that's going to go in a circle. Okay, and then if we take this view, we're going to say that's our radial direction, that's our z direction. Okay, and there's some theta below that's going to drop below the horizon. Horizontal, not horizon. Okay, so our free body diagram for the rock will look like this, right? So we have force of gravity going down, and then we have tension at some angle, and tension is going to have the same y component, right, as gravity, because we're not going to have any acceleration in there. And then it's also going to have an x component that will provide the centripetal force. So in the diagram, they say that angle is theta. We could draw our tension like that as well, and this is theta, right? Those are alternate interior angles of a parallel line. Okay, so let's apply Newton's second law. It's our favorite. Sum of the forces is mass times acceleration. We're just going to write our forces down from the free body diagram, not care about directions yet. So we have tension, and we have the force of gravity. That was kind of a weird vector there. Okay, and then that produces our acceleration, ma. Okay, now we break them into components. So we can write each vector as a column vector. We're going to put R on the top row, Z on the bottom. So that's for tension. And then we have the force of gravity. All right, so tension in the radial direction, but that's the side adjacent to theta, right? Sine theta equals TR over the hypotenuse T. Oops, nope, that's cosine. You guys should tell me when I'm wrong. Okay, right, that's our adjacent over hypotenuse side. And then for our opposite side, sine, we're going to get our TZ component over T. Okay, so our R component is T cos theta, and our Z component is T sine theta. Gravity is has nothing in the radial direction, and it's minus Fg in the Z direction. Mass just comes in and multiplies each component of acceleration, MAR. Force of habit, MAZ. Okay. So our radial direction acceleration is 0. Okay. Our Z direction, my gosh, you guys, I need another cup of coffee. Okay, and our radial direction acceleration is v squared over r. It's actually asking us to find this in terms of omega, so you remember that v is omega r. So if I plug that in here, my radial acceleration is omega r squared over r, which is omega squared r. Okay, so let's write our equations out now. We're going to pull out our radial equations, ignore the dogs next door. I try to ignore them. T cos theta equals m omega squared r, but they do get to be a little bit annoying. Okay, and then our z equation is T sine theta minus Fg equals 0. Okay, so T sine theta equals mg on that side. Okay, I had to think about this. I haven't, of course, I've done this problem a gazillion times, but our unknowns here, that we don't know, we actually know tension. Usually that's something we're going to solve for, right? But we know that T max is we're going to set it equal to 200 newtons, the maximum tension, and then also solve for the maximum angular speed it can have. Okay, so our unknowns are theta and omega. Okay, so I can solve for theta over here. Actually, I know everything except theta. So I have sine theta is mg over t, and again, I'm using T max for that. So theta equals inverse sine of mg over t, so mass is 1 kilogram, g is 9.8 meters per second squared, and then the tension is 200 newtons. So if I solve for that, I get that theta is 2.81 degrees. Okay. All right, so now we're back over here, and we can try and solve for omega. And one little bit of information here. So if we look at the geometry of the rope here, something like that, right? So that's the length we know of the vine is 1 meter. But the radius of the circle is actually this leg of that triangle. Same geometry, so theta is still in there. So our radius actually is L cos theta, a little snag we have to overcome. Okay, so now we can bring our R equation down and solve for omega. So if we get omega by itself, we have T cos theta, and we're going to have to divide through by m and r, and that would leave omega squared on the right side. And then we can take the square root and swap our sides. So omega equals the square root of T cos theta. I'm going to squish things in here just so I can stay on this page. Remember, r we said was L cos theta. Okay, so that actually goes away. And so we get omega is just equal to 200 newtons divided by my mass, which was 1 kilogram, and my length, which was 1 meter. It's really just the square root of 200 is the value. And if we look at our units, right, we have a newton, which is a kilogram meter per second squared. We're dividing by a kilogram, and we're dividing by a meter. So those go away. So we're getting 1 over a second squared, and then we take the square root of that. So our answer will come out as 14.1 radians per second. Okay, that's our angular velocity. All right, and just when you think you're done, you're not, because it said, what is omega in RPM? That's revolutions per minute. And I just think of these as unit conversion problems, right? So down in the bottom now, my last line, I know omega is 14.1 radians per second. And now I want to convert to revolutions. Okay, so I want revolutions on the top. I want to get rid of radians. And I know 1 revolution is 2 pi radians. Okay, and then I need minutes on the bottom. I have to get rid of seconds, keep minutes. And I know 1 minute is 60 seconds. So if we multiply all of our numbers out, our radians go away, our seconds go away, we get revolutions per minute, and the value is 135 RPM. And I think the dogs like that answer.